The 6 trig functions start with the 3 basic ones, and you remember that you can get those by SOHCAHTOA. The definition is sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. And from those, you can get the other 3, because the other 3 are actually reciprocals. So if you knew what the sine is, the reciprocal of the sine is the cosecant, which is hypotenuse over opposite. I would always think about these 3, and then the reciprocals would be these 3. Notice that cosine and secant go together, C and S. Same thing here, sine and cosecant, S and C. And then you just have the other 2. So you're thinking basically these 3 and then the reciprocals give you the other 3. Furthermore, you can see that from the special right triangles, you can develop a table, such as the sine of 30 degrees, you know, as the ratio is 1/2, so the sine of 30 is 1/2. Now the reciprocal of that is 2, so that means that the cosecant of 30 degrees is 2 because those are reciprocals. If you line them up, the sine and cosecant, then all you're doing is thinking about reciprocals. Doing a few problems. First of all, on this one, let's say that this is equal to 12. There are Pythagorean triples, and the Pythagorean triples come up very often. They are the sides of 3, 4, and 5, and or multiples of 3, 4, and 5. Also 5, 12, 13, 7, 24, and 25, and 8, 15, 17, or any multiples of these. In other words, 3 squared plus 4 squared equals 5 squared. 5 squared plus 12 squared equals 13 squared. Looking at this triangle now, if you know that, you can see that the legs are 5 and 12, so the hypotenuse has to be 13 without using the Pythagorean theorem. Only certain triangles follow this pattern, so you can't assume that the triangle is automatically one of those. Also, these have to be in the correct order or location. So the legs have to be 5 and 12. Hypotenuse has got to be 13. If you had 5 and 13 here, you know that that has got to be a 12 because it's the leg. Once you have that, I would write down all of the 6 trig functions on what you're trying to find. Now, notice that I would write these in a very specific order because I want to not think as hard as I have to. And when I write them in reciprocal order, then evaluating them becomes a lot easier. Sine theta, opposite over hypotenuse, 12/13. Cosine theta, adjacent over hypotenuse, 5/13. Tangent theta, opposite over adjacent, 12/5. And now I just write down the reciprocals of those first 3 trig functions. And that's all there is to it. If it's not a special Pythagorean triple, then you'd have to use the Pythagorean theorem to figure out this side, right? It'd have to be 7 squared plus b squared equals 19 squared, and you'd have to solve it for your b. You may have problems like this that don't have a triangle, and if you don't have a triangle, you have to make a triangle and get that third side. So in this one, I'm going to create a triangle and I put my theta in here. And this opposite side is 3/7. And again, you have to figure out what that side is. So 3 squared plus what squared equals 7 squared. B squared equals 40, or in other words, 2 square roots of 5. That's going to give you the other 6 trig functions. So now 2 square roots of 5 is that third side, which means I can write down the cosecant, which is equal to 7 over 3. It's the reciprocal. Then I can go and get the cosine of theta. I'm just going to leave these in non-simplified form. 2 square roots of 5 over 7. That tells me that the secant of theta is the reciprocal. Again, S's and C's, I'm matching them up. 7 over 2 square roots of 5. And tangent theta equals 3 over 2 square roots of 5. And the cotangent of theta is the reciprocal, which is 2 square roots of 5 over 3. Again, pairing them up as reciprocals. Learning the 6 trig functions isn't that hard if you just think about the 3 SOHCAHTOA trig functions and then the other 3 as reciprocal functions to those 3.